Okay, on page 197, we have example 3. There is a graph that looks like a parabola that's opening upward, and the question that says, is it a quadratic function? So here are the points that we've pulled from that graph. The first thing I need to do is decide if it's a function. So look at your inputs. They are consecutive, and they're all different, so yes, it's a function. It passes the function test. Does it pass the one-to-one test? And no, it does not, because I have the 81 twice, the 16 twice, and the 1 twice. So it's a function, but it is not one-to-one, which I would expect that to be the case with a quadratic because it makes that bowl shape. Okay, so let's test the consecutive differences. I can look at the graph and tell you that it's not linear, but we need to get these numbers to be able to get the next column. So everything builds on the column before. You start off with that independent variable, the x's, then you get the dependent variable, and then you can test the differences. So we have 16 minus 81. And where's my calculator? I'm not even going to attempt it. Not only are they not lined up, they're backwards. So negative 65. Then 1 minus 16 is negative 15. Then 0 minus 1 is negative 1. 1 minus 0 is positive 1. 16 minus 1 is 15. And then 81 minus 16 is positive 65. So this is definitely not linear, but we knew that. Okay, so let's test to see. It's looking like it's going to be a quadratic. So maybe I should just go ahead right now and say, yes, it's a quadratic. Or maybe not. You think that's a safe bet, or do we need to check it? I'm going to go with experience and say we need to check it. Especially after they just gave me one that proved to be true. Okay, so now we have a negative 15 minus a negative 65. Be careful there with all those negatives because that gets really weird in a hurry. So that's a 50. And then I have a negative 1 minus a negative 15. That's going to be 14. Then I have a 1 minus a negative 1. That's going to be a 2. Then a 15 minus a 1 is a 14. And a 65 minus a 15 is 50. It looked quadratic. Even the graph looks quadratic. But at this second degree, it's not common, so it's not a quadratic. It looks like a duck and it acts like a duck, but in this case, it's not a duck. And you will not know that unless you plot those points on this chart and calculate your consecutive differences. So is it a quadratic function? No. That's a good